Hi, welcome to Haywood's Maths. Today we're looking at compound interest and we're looking at a special type of compound interest. If you've never heard of compound interest, it's a thing where you can make money on your interest. So if you put $100 in the bank, so if you put $100 in, maybe it's compounding monthly. That means you'll get money back after a month. At the end of the first month, you'll have $110. The next month, you'll have the $110 plus the interest you earn on the first month. Let's say it's $11. So you're earning interest off your interest as well. So that extra $10 will get you that extra dollar the second month. And this is what compound interest is. Now that's compounding monthly. You can also compound yearly. You can compound every second year. You can compound like fortnightly. Normal compound interest formula looks like that. And this is if it's compounding yearly, if it's compounding every month, if it's compounding every fortnight, if it's compounding every week, if it's compounding every day. And you see, as n goes towards infinity, what happens is this special formula, which you're used to in different forms, changes. It becomes the principal times the special e function, which hopefully you've seen before, an exponential function, and it's e to the rt. So this bit inside the original equation, 1 plus r over n to the power of n, as n goes to infinity, it becomes e to the r instead. And you insert that into the equation and it becomes a equals pert. Okay, so this special formula, when it's compounding every single second, is called continuously compounding. And it's only when the number of terms is close to infinite. So it's compounding continuously. Every second it's compounding. Okay, so pretty much this isn't ever offered, this continuously compounding situation. Most banks offer monthly compounding. Okay, so imagine I have $41,000 and I find these special banks. Okay, so considering these two rates, Commonwealth Bank, pretty much what most other banks are offering, Westpac and all of those, 0.8%. Judo offering this. They are both compounding continuously. We want to find out if I put a little bit more in the lower rate and a little bit less in the higher rate, when will they equal each other? So how long will it take before the Judo Bank catches up with the smaller amount? There's only a $1,000 difference, but let's see what happens. You can do this algebraically. So you can use this formula, which I just introduced to you, and shove in the two amounts. So let's put in the CBA, Commonwealth, put in a principal, of 21,000. This funny e function, the rate is 0.8%, so we're going to divide that by 100 to get it to a decimal instead of a percentage. And we don't know the time. Okay, we want to know when they are equal. So Judo Bank. So we want to know when the final amount, capital A, is equal to the other final amount. So the other account, I'm going to put in 20,000, and it has a rate of 1.45%, or written as a decimal like that. Okay, so we want to find what t is. We've got to use some log rules here. So first of all, let's divide by 20,000 on both sides, and let's divide by this e function. So when I divide it by the left side, it disappears. And now the right side has two e's over the top of each other, like that. Okay? So the left side of the equals, that becomes 21 over 20. The right side, remember indice laws, an divided by am equals an minus m, like that. So this becomes e 0.0145t minus 0.08t. Oh, whoops. Missed a 0. Okay? Now, how do we get rid of that e? Alright, so how do we get rid of that e? So how do we get rid of that e? We have to do the opposite of e, or the inverse of e, which is log base e. So if we do log base e to both sides, the log base e cancels out the e, and we're just left with the power. Oh, I forgot the t. There we go. And now if we divide both sides by 0.065, you're just left with t by itself. So that's how I got t by itself to solve when these two accounts are going to be equal to each other. If I put slightly less into the higher rate account. And I've already done this previously. And look at that. It'll take approximately 8.13 years. I'll show you on a calculator. Alright, so I'm going to use the TI-Nspire. So if I go to graphs, the graph has a y-axis and an x-axis. In our equation, the unknowns are a and t. So these both equal a. So instead of a, I'm going to use y. Instead of t, I'm going to use x. It'll get the same thing. I just have to use different letters. So let's do the first account. This is the Commonwealth Bank account. Let's see how much it gives me. Okay, so a equals 21,000 e to the power of 0.008x. Now I'm going to have to zoom out a bit. The starting amount, or the y-intercept, is 21,000. So let's go up to 40,000. There we go. Okay, so if that's 21,000, it's going to be not quite 30,000 after 30 years. Okay, so probably like 27,000. All right, let's try another account. Control G to put in another one. So let's try the judo percent. Okay, and look at that. You can already see how much steeper it is. So see how much of a difference that small increase of rate changes over the 30 years. So you're going to get way more. And this again is only for continuously compounding, which isn't commonly used, but it is pretty close to monthly compounding or fortnightly compounding. There isn't too much of a difference in the scheme of things. Anyway, I hope that's been useful, especially maybe if you're thinking about interest accounts or loans or anything like that. Don't forget, a loan is a bit different because they're taking money from you. So just keep that in mind. Thanks for watching.